Lesson 6, the lesson essential question is how can I describe functions? And we just completed the exploration. And now we're going to do our guided notes and practice. So in our exploration, we looked at tables, equations, and graphs. And there were certain things that we checked with each of those representations, and it helped us determine whether the function would end up being linear or nonlinear. So when it was a table, we checked the rate of change. When we were looking at the equations, we looked at x in the equation to see if there was an exponent or not. And for a graph, we looked at the line created when we graphed the function. Okay, so if our table had a constant rate of change, then it was a linear function. If the rate of change was not constant, then it was nonlinear. Equations, if x had an exponent, it was nonlinear. If there was no exponent, then it was linear. And the line, if it was a linear function, then the line was straight. If it was nonlinear, it was curved or not straight. So we're going to use these notes to complete the problems. So let's check out this first table. We're going to have to look at rate of change because it's a table. So I'm going to look at my input values first. From 10 to 20 is plus 10. 20 to 30 is plus 10, and 30 to 40 is plus 10. So there's a constant rate of change. Now we need to look on the other side. So from 15 to 45 is plus 30, and from 45 to 25 is a minus 20, decrease of 20. So there is definitely not a constant rate of change. So that means that this table, the function that it represents, would be nonlinear. In the justification, the rate of change is not constant. All right, next we have an equation, and we know when we're looking at equations, we're going to check x. If it has an exponent, then it's going to go off on an expedition and be curved. No exponent, it's going to be linear. So here is my x. There is no exponent on it, so that means that it would be linear. In the justification, no exponent. Okay, the graph. We're going to check the line of the graph. This is definitely a straight line, so that means that it is a linear function. Justification, the line is straight. All right, next table. Again, we're going to look at the rate of change. So from 2 to 4 to 6 to 8 is an increase of 2 each time. From 3 to 5 is an addition of 2. And from 5 to 9 is an increase of 4. So we do not have a constant rate of change. So this is nonlinear. Again, rate of change, not constant. Equations, we're going to check x, and I see that x does have an exponent. So that means that it will be non-linear. Justification, there's an exponent. Okay, next graph, checking the line, and it is straight. So that means that it is a linear function. Justification, straight line. All right, last three. In this table, we're going to check the rate of change. From -4 to -1 is an increase of 3. From -1 to 2 is also an increase of 3. And from 2 to 5 is an increase of 3. So far, so good. Now let's look at the bottom. 0 to 5 is an increase of 5. 5 to 10 also, and 10 to 15. So we have a constant rate of change here. That means this function is linear. Constant rate of change. All right, we have an equation. We're going to check x, and x does not have an exponent, so it would be linear. It has no exponent. And our graph. Looking at this line, it is definitely not straight, so that means it is non-linear. It has a curved line. Oops, line. Okay, so those are our guided notes and practice on how to describe functions.